See, MLE of alpha is x1 and beta is the nth order statistic if f of x is 1 by beta minus alpha when x is between alpha and beta. X lies between alpha and beta. To find the MLE here, the fact we should understand is the order statistic. The order statistic which is very close to alpha is x1. So it contains maximum information about this parameter alpha. This is a particular distribution in which the interval contains the parameter. Okay. So here to estimate beta, xn is the maximum likelihood estimator. MLE, nth order statistic is the MLE. Since the nth order statistic contains maximum information about beta. So the statement that MLE of alpha is the first order statistic and MLE of beta is the nth order statistic is true. Okay, fine. Now let us try to remember some important points. The standard error of a statistic of the sample mean x bar is sigma by square root of n. So the precision of x bar is, the formula for the precision of a statistic is 1 by standard error of the statistic. So the precision is root n by sigma. And standard error of the sample proportion is root of p cap q cap estimate of p into estimate of q divided by n, and the precision of p is root n by p cap q cap. Okay. Now let us remember the confidence interval, 95% confidence interval, 90% confidence interval, 99% confidence interval, and more probable limits for the sample for the population proportion p and the population mean mu. So here it is p bar plus or minus 1.96 into square root of p cap q cap by n, and p bar plus or minus 1.645 into standard error of p, which is this. P cap, it is actually p cap. Okay, p bar 2.58, 99% confidence interval is 2.58. And most probable limits is most probable, this. And for mean, the population mean, it is x bar plus or minus 1.96 into sigma by square root of n. Here it is x bar plus or minus 90% is 1.645 into sigma by square root of n. X bar plus or minus 2.58 sigma by square root of n, and here the most probable limits are nothing but 3 sigma limits. Okay, fine. So how we got this? We got this with the idea that a statistic minus expected value of that statistic divided by standard error of the statistic is the test statistic. Okay. When the sample size is large, this follows Z distribution, and based on which we derived the formulae for the confidence interval. Right? Now, the next one. So, confidence interval for variance is n s square by chi square alpha by 2, comma n s square by chi square 1 minus alpha by 2. By chi square alpha by 2, we mean The area here is alpha by 2 and the ordinate is named as chi square alpha by 2, meaning that the area after that ordinate is alpha by 2. Okay. Now confidence interval for mean when the sample size n is small. The confidence interval formula is x bar plus or minus t alpha by 2 at n minus 1 degrees of freedom into s divided by square root of n. Okay. Now, in some situations, we will be asked to find the sample size for a given precision. See, we know this is the standard normal variate. Okay. X bar follows if x follows normal distribution with mean mu and variance sigma square, x bar follows normal distribution with mean mu and variance sigma square by n. So x bar minus mu divided by its standard deviation sigma by root n follows z distribution. Right? Now the difference between the statistic and the parameter, if the allowed value is e, in some cases this will be given, this will be given and this will be known, of course taken from the table. You will be asked to find the sample size, the required sample size to achieve a given precision. So here it is this, right? Which means z is the sigma divided by e is square root of n. So what is the sample size then? Z sigma by e the whole square, right? So this is the formula for finding the sample size when you are testing the mean, right? Population mean based on large samples. On the same grounds, see, this statistic also follows Z distribution. So here again I take this as B, the precision that is required, the sample error, the difference between the statistic and the parameter, divided by P cap Q cap by N. So which implies Z is equal to E into square root of N divided by P cap Q cap, which implies square root of n is equal to E into square root of P cap Q cap, Z into square root of P cap Q cap divided by E, which implies n is equal to, you square on both sides, Z square PQ divided by E square, right? Z square PQ divided by E square is the formula for finding the sample size when you are testing the population proportion. Okay. These two formulae are used to find the sample size, determine the size of the sample that is required. Okay. So with this idea, let us go to the questions. The precision of your statistic t is 1 by standard error of t, right? As the sample size increases, the standard error decreases and precision increases. Okay. As sample size decreases, standard increases, standard error decreases and precision increases. Okay. So if we improve the sample size, we will get better results. That's the idea. The standard error of sample mean is standard error. This is the variance. Okay. Standard error is sigma by square root of n. The precision of the sample mean is, precision is the reciprocal of the standard error. So it is square root of n by sigma. Okay. The standard error of sample proportion is this one, root of estimate of P into estimate of Q by n. The precision is just the reciprocal of it. Okay. The most probable limits of population mean is this. 3 sigma limits are the most probable limits. Okay, let us match it. 95% confidence interval. The table value will be 1.9696, and for 90 it is this. For 99 it is 2.58, and most probable limits are nothing but 3 sigma limits. Okay. For finite population, the standard error is, see actually the standard error is sigma by square root of n. For x bar, the standard error is sigma by square root of n. But for finite population, it is sigma by square root of n into this factor, which is called finite population correction. So what is finite population correction? For a finite population, you should multiply this with root of n minus n by n minus 1, which is called finite population correction. Okay. The confidence interval for the population mean based on small sample. Based on small sample is this. X bar plus or minus t alpha by 2, because you should have alpha by 2 at both the tails, and this is 1 minus alpha. The standard error is s by root n. So it is x bar plus or minus t alpha by 2 comma n minus 1 into capital S by root n. The confidence interval for population proportion is this. ns square by chi square alpha by 2 comma ns square by chi square 1 minus alpha by 2 within bracket. Now find the sample size n for the for estimating the population mean when sigma is equal to 3, error is equal to 0.8, sample error is 0.8, and the confidence level, that is 1 minus alpha, is 0.95, which implies alpha is 0.05, which implies z alpha by 2 is 1.96. Okay. So what is n? Sample size n is, what is the formula for n? Sigma z by e the whole square. 3 into 1.96 by 0.8 the whole square. Right? You work it out. You get the answer as approximately 54. Okay. Now, the formula to find the sample size for a given sample error E, confidence level 1 minus alpha and sigma is, this is the formula, right? No, this is the formula. The formula to find n for estimating the population P is z square pq by e square. This is the form. Okay. Thank you.